Lewis Hamilton has never been known as the most aggressive driver on the Formula One grid. He rarely looks spectacular in the way some drivers do, and his laps often appear calm and controlled rather than dramatic. Yet engineers and analysts consistently describe Hamilton as one of the smoothest drivers in Formula One history. Even after nearly 2 decades in the sport, Hamilton continues to demonstrate a level of control that allows him to extract performance in situations where other drivers struggle. The real question is not just why Hamilton is smooth, but why smooth driving still works in modern Formula One, even as cars become faster and more complex. Smooth driving in Formula One does not simply mean gentle steering inputs or calm movements. Smoothness is about maintaining control over the car's balance so that the tyres operate within their optimal grip range. Formula One tyres provide maximum performance only within a narrow temperature window. If drivers push too aggressively, the tyres slide and overheat, causing grip to decrease rapidly. Drivers who maintain smooth inputs prevent unnecessary sliding, allowing tyres to remain within their optimal operating range for longer periods. Hamilton's driving style minimizes tyre stress by reducing unnecessary movement. When entering corners, Hamilton often applies steering inputs progressively rather than making sudden corrections. This allows the car to settle into the corner without abrupt weight transfers. Stable weight transfer improves tyre contact with the track surface, increasing grip and reducing wear. Over the course of a race distance, these small differences accumulate into significant advantages. Tyre management has become one of the most critical elements of modern Formula One performance. Cars generate enormous aerodynamic loads, and tyres must withstand extreme forces during acceleration, braking, and cornering. Drivers who preserve tyre performance gain the ability to maintain competitive pace late into stints. Hamilton has repeatedly demonstrated an ability to extend tyre life while maintaining strong lap times. This characteristic often allows him to remain competitive even when rivals initially appear faster. One of Hamilton's key strengths is his ability to feel the limits of grip through the steering wheel and pedals. Experienced drivers often describe this sensation as feedback from the car. Hamilton's sensitivity to this feedback allows him to detect early signs of tyre overheating or loss of grip. Instead of pushing beyond the limit and damaging the tyres, Hamilton adjusts his driving style to maintain stability. This ability to sense and respond to changing conditions contributes significantly to his smooth driving style. But Hamilton's smoothness begins even before the car reaches the corner. One of the most important aspects of his driving technique is braking control. Braking is one of the most critical phases of a lap because it determines how effectively the car enters corners. Sudden or aggressive braking can destabilize the car, causing tyres to lose grip. Hamilton typically uses progressive braking, gradually increasing brake pressure before smoothly releasing it as the car approaches the apex. This technique maintains balance and prevents unnecessary tyre stress. Smooth braking also allows Hamilton to position the car precisely for corner entry. Accurate positioning improves cornering efficiency and reduces the need for steering corrections. Fewer corrections reduce tyre wear and maintain stability. Hamilton's braking technique often allows him to carry speed into corners without compromising control. Another important element of Hamilton's smooth driving style is throttle control. Modern Formula One cars produce enormous power, and applying throttle too aggressively can cause wheel spin. Wheel spin overheats tyres and reduces acceleration efficiency. Hamilton typically applies throttle progressively, allowing tyres to maintain grip while accelerating out of corners. Smooth throttle application reduces tyre stress and improves exit speed. Exit speed is particularly important because it influences performance on following straights. Drivers who accelerate efficiently gain advantages that continue for entire sections of track. Hamilton's ability to combine smooth throttle inputs with stable cornering allows him to maintain consistent lap times across long runs. Steering control also plays a major role in Hamilton's smooth driving style. Drivers who turn the steering wheel too aggressively create excessive lateral loads on tyres. Excessive loads increase wear and reduce grip. Hamilton typically uses controlled steering inputs that allow the car to rotate naturally through corners. This technique reduces sliding and improves efficiency. Smooth steering also improves aerodynamic stability. Formula One cars rely heavily on aerodynamics to generate downforce. Sudden changes in car attitude can disrupt airflow, reducing downforce and grip. Smooth inputs maintain stable aerodynamic performance, allowing the car to operate efficiently at high speeds. Hamilton's smooth driving style has proven particularly effective in changing conditions. Wet races and mixed conditions often reward drivers who maintain precise control. Reduced grip levels make aggressive driving risky because small mistakes produce large consequences. Hamilton's ability to maintain smooth inputs often allows him to perform strongly in difficult conditions. Over the years, Hamilton has demonstrated exceptional performances in wet races where smoothness becomes critical. Controlled inputs allow drivers to maintain grip when track conditions are unpredictable. Smooth drivers often detect grip changes earlier, allowing them to adjust driving styles before losing control. Another important aspect of Hamilton's smoothness is consistency. Maintaining consistent lap times requires precise control and concentration. Hamilton often produces long sequences of competitive laps with minimal variation. Consistency reduces strategic risks and allows teams to plan race strategies more effectively. Consistency also builds confidence between drivers and engineers. Engineers rely on predictable driver feedback to make setup adjustments. Smooth drivers produce clearer feedback because their driving inputs remain consistent. Hamilton's communication with engineers has often been praised for its clarity and usefulness. Car setup also interacts with driving style. Drivers who prefer smooth inputs often benefit from stable setups that provide predictable behavior. Stable setups allow drivers to push closer to the limit without sudden loss of control. Hamilton has often preferred cars that provide strong rear stability and predictable front-end response. Stable setups reduce driver workload by making car behavior easier to anticipate. Reduced workload allows drivers to focus on optimizing lap times rather than correcting instability. Hamilton's ability to work with engineers to achieve stable setups contributes to his smooth driving style. Hamilton's smoothness is often contrasted with the more aggressive style of drivers such as Max Verstappen. Aggressive drivers often rely on rapid car rotation and sharp inputs to achieve fast lap times. These styles can produce impressive qualifying performances, but may increase tyre wear over race distances. Smooth drivers often produce stronger long-run pace because they preserve tyre performance. Different driving styles can produce similar lap times under ideal conditions, but smooth driving often provides advantages when conditions change. Races rarely remain perfectly predictable, and drivers who adapt effectively gain advantages. Hamilton's smooth style allows him to respond to changing conditions without dramatic adjustments. Modern Formula One cars have become heavier and more complex, increasing the importance of tyre management and energy management. Smooth driving reduces energy losses caused by sliding and instability. Efficient energy use improves performance over race distances. Hamilton's style aligns well with the demands of modern Formula One. Looking toward the future, smooth driving may become even more important under the 2026 regulations. The next generation of Formula One cars will rely more heavily on electrical energy and may produce different aerodynamic characteristics. Efficient driving will likely become critical for maximizing performance. Drivers who manage tyres and energy effectively may gain advantages under new regulations. Hamilton's smooth driving style suggests he may remain competitive even as cars evolve. Experience and precision often become more valuable as technical complexity increases. Smooth driving does not always produce dramatic visuals, but it often produces consistent results. Hamilton's ability to maintain control and efficiency has allowed him to remain competitive across different eras of Formula One. From high downforce V8 cars to hybrid-era machines, Hamilton has adapted his driving style while maintaining core strengths. The reason Hamilton is still one of the smoothest drivers in Formula One is not simply experience or natural talent. It is the result of precise control, tyre awareness, braking technique, throttle modulation, and consistency. Each element contributes to a driving style that extracts performance while preserving stability. And in a sport where small differences determine results, the ability to drive smoothly remains one of the most effective ways to stay fast, even after nearly 2 decades in Formula One.